All right, we're reviewing inductive reasoning, conditionals, and deductive reasoning. All right, so we got the sequence. We want to find the next term. And so let's notice some things about the sequence. It appears that the triangle is kind of rotating in this direction, 90 degrees in that direction. So my next one, and I'm just going to draw a sketch of this. The triangle will be something like that. So that's the first thing that I'm noticing as far as looking at those triangles. I'm also noticing that the dots, little dots in the corner, are increasing. So this next one needs to have one more than 3, 4. And that's in the right, where the right angle appears to be. Now we don't have any markings to know for sure, but so I need 4 dots there. Oh, I'm also noticing that we have these 4 parallel lines there. This one has 3, this one has 2, and so one less each time. And so hopefully I can draw this good. Appears that this last time we'll just have one of those. So just kind of scan through it, look at it one more time before you move on to the next problem. All right, so the triangle's rotating in a clockwise manner, 90 degrees. The dots are increasing by 1, and then the lines that are parallel to one of the legs are decreasing by 1 each time. We start out with 4, then 3, then 2. Now this next one would have 1. All right, so everything looks approximately good. All right, here let's try to figure out a pattern. So it looks like after the first term, just this piece of the first term is moving on to the next one. It's like one diagonal of steps is taken off. So if we take off another diagonal, now we're here. If we take off this next diagonal, then we would just have a square. All right, here we have numbers. It's increasing, so I'm thinking either multiplication or addition. If I think addition, add 4, add 12. Not sure what the pattern might be. Now let's think about multiplication. As we go from left to right, we multiply by 3, and then we'll multiply by 3 again. So it has that same pattern. So multiply by 3. So 18 times 3 will give us 54. So our next term is 54. If you're not able to see that multiplication as you go from left to right, then you could try dividing by the previous term. 6 divided by 2 is 3. 18 divided by 6 is 3. And so it is 3 that's the number we're multiplying by. This is a geometric ratio, or geometric sequence, I should say, by the way, when you multiply by the same number each time. All right, here we're increasing as well, so I'm thinking maybe add 7. Yeah, looks like that's good. So add 7 one more time, and we get 35 for the next term. So inductive reasoning, you're looking at observations or examples to try to make a prediction, try to make a conjecture. Here we have a conditional, if P, then Q. We want to write the inverse. For the inverse, it's going to be if not P, then not Q. The inverse negates both. So we will say if a number is not a multiple of 10, then it is not a multiple of 5. Now, we're not concerned on this particular problem whether these things are true or false. We are just coming up with our inverse. To come up with your inverse, you negate both. So you put the word not in there, or if the word not happened to be in the original conditional, you could take that word out so that you would negate that, so that you would have the opposite meaning. Number 6, we're trying to write the contrapositive. Contrapositive will negate and reverse. So this is my original conditional, if P then Q. Contrapositive negates and reverses. So if not Q, then not P. So we're going to take this conclusion of the first, negate it, and put it at the beginning, reverse it. So we can say, if you cannot get your driver's permit, then, and then we'll negate the hypothesis, then you are not 15 years old. So again, notice the word not, we put it with the cannot. We negated both and we reversed them for the contrapositive. Contrapositive and the conditional are logically equivalent. They always will have the same truth value. Now it says to determine the truth value or determine whether the contrapositive is true or false. If you cannot get your driver's permit, then you are not 15 years old. Can you think of any time where someone cannot get their driver's permit, but they are 15 years old? In general, I would say this is true. You would have to think of some really extreme cases that people that could not get their driver's permit, but they are 15 years old. So I would say in general this is true. If you're going to say false, you need to come up with a counterexample. And so I would have to see your counterexample to decide whether I think that's a valid statement. But I'll go with true. Converse. So here's your conditional, if P then Q. The converse reverses those. So if Mr. Swayze tutors, then it is Wednesday. Not told to do the truth value or anything, just write in the converse. Converse, so this is our conditional, and then this is our converse. Converse reverses both. Changes the hypothesis and the conclusion, reverses those. Number 8, write a statement that's logically equivalent. Logically equivalent to the conditional is a contrapositive. So we're going to negate both and reverse both. That should be a P. All right, so we would say if a number is not an integer, if a number is not an integer, then it is not a whole number. a contrapositive and the conditional are always logically equivalent. They always have the same truth value. Number 9, we've got an if P then Q. If it rains, then the ground gets wet. Then we have an if Q then R, so a new statement. If the ground gets wet, then the grass grows. And then we have an if R then S. Now, as long as the conclusion of one matches up with the hypothesis of another, you can put them together. The conclusion of one matches up with the hypothesis of another, you can put it together. So now we can say if P then S. So if it rains, then the lawn will need to get cut. If you remember the direct TV commercial that we looked at, you can put tons of these together using that law of syllogism. Conclusion of one can match up with the hypothesis of the other, and you can just keep on putting them together. Determine whether statement 3, so this last one, follows from statement 1 and 2. So 1 and 2, the order doesn't matter on that. Let's see, it says two angles have the same measure. So we could say that that is P is true. And then we have if P, then Q. If two angles have the same measure, then they are congruent. So that's a true conditional. So we have a true conditional and we have the hypothesis is true. Using the law of detachment, then we can say that the conclusion must be true. So determine whether it's valid. So yes, it's valid by the law of detachment. Law of syllogism has to have two conditionals. This only has one conditional. So the law of detachment has a true conditional, and we know that the hypothesis is true, then the conclusion must be true. All right, see if this works with the law of syllogism. If P, then Q. If you live in Los Angeles, then you live in California. If you live in California, then you live in the United States. And so, yes, we can put them together. If P, then R. If you live in Los Angeles, then you live in the United States. So yes, this is a valid time to use the law of syllogism. Now, if just both conclusions matched up, then it would not be valid. We could not put them together for something. The conclusion of one needs to match up with the hypothesis of another. That's when you can use the law of syllogism. Find a counterexample. Something that makes the first part true and the second part false. If an angle is acute, then it measures 50 degrees. Well, let's suppose we have the measure of angle A is 60 degrees. Is that acute? Yes, it's acute. Does it measure 50? No. So that's a good counterexample. Now, there's lots of different acute angles. So if you said 53, if you said 78, if you said 89, any angle that's between 0 and 90 that is not 50 will be a valid counterexample. Determine whether the conjecture is true or false. I'll have to admit this one's a little bit tricky. Let's solve this equation and let's see if we come up with any other solutions. To get rid of plus 1, subtract 1. We have m squared equals 16. To get rid of squared, square root. When we square root both sides, we have to remember about the positive or negative square root. And so we get positive or negative 4. So that means our conjecture that m is 4 is not correct. M could also be negative 4. So this is false. because m could equal -4. Now, if the conjecture said m is 4 or -4, then that would be correct. So notice that this is false because we have a counterexample. We have another value for m that's not listed. 14, if the sum of two numbers is negative, then both of the numbers are negative. So let's think about if we can add two numbers whose sum is negative. Are those two numbers that we're adding together, do they have to both be negative? Now the first part has to be true. The sum of the two numbers must be negative. -5 plus 3, that's -2. But the conclusion must be false for it to be a counterexample to a conditional. Then both of the numbers are negative. Think about these two numbers we're adding together. They're not both negative, and so this is a good counterexample. Now there are lots of others. You might have said -2 plus 0. You could have said -100 plus 12. There are lots of different things that make the first part true, the second part false. When that happens, then it's a good counterexample because that will make the conditional false. All right, filling in this truth table, not P or the negation of P just means the opposite truth value. So if P is true, then not P is false. If P is false, then not P is true. And in fact, I guess I could have given you a little simpler version of this. I did not think about that. You only have P, so the only possibilities are either true or false. So this will be a little simpler version. If P is true, then not P is false. If P is false, then not P is true. So just the opposite, truth value. For a conditional, the only time it's false is if the first part's true and the second part's false. That happens here. Every other time it's true. If the hypothesis is true, then the whole statement must be true. Excuse me, I said that wrong. If the hypothesis is false, the whole statement is true. The condition has not been met. The hypothesis has not been met. So the conclusion does not have to be true for the whole statement to be true. The example I used originally in class was, if I win the lottery, I'll give you each $20. The only time you can prove that I'm being dishonest or telling a lie would be right here. If I actually won the lottery but then did not give you each $20. All right, so hopefully this review helps. Make sure you're good with those truth tables for conditional and negation. I'll simplify that negation one. Make sure you're good with finding some counterexamples. Inductive reasoning, deductive reasoning, be comfortable with both the law of detachment and the law of syllogism. And for conditionals, make sure you're good with writing the converse, inverse, contrapositive. Conditional and contrapositive are logically equivalent. Anytime you're looking for a counterexample to a conditional, you need to be thinking through this row. First part must be true, second part false. That proves a conditional false. All right, hope you've enjoyed that video. Hope you learned something. Study for your test. Peace.